Over 3 centuries past, Newton found inspiration under an apple tree, proposing the trio of motion laws and universal gravitation law, which laid the groundwork for classical mechanics. These laws found use in many areas, but only detailed gravity's effects without explaining its origin. Einstein also probed gravity, pondering its nature. For instance, an apple on a table stays put. But if the supporting hand is removed and all objects underneath, the apple keeps falling down. Einstein recognized gravity's link to the falling apple. When the apple is thrown, it traces a curved route. By increasing the apple's speed to 7.9 kilometers per second, the initial cosmic velocity, it won't return to the ground, but will orbit Earth. Einstein deduced that apples, space stations, and astronauts are all free-falling entities tracing curved routes in space, shaped by Earth's mass. He concluded that space and time bend due to massive objects like Earth. The Sun's mass, for instance, bends the surrounding space, making planets follow curved paths in this warped space without external forces. Objects moving in straight lines can only adhere to space's curves. In Einstein's general theory of relativity, gravity results from an object causing space to curve. This theory can predict black holes, but it was German physicist Karl Schwarzschild, not Einstein, who connected gravity to black holes. In 1915, as Einstein presented his general theory of relativity, Schwarzschild served in the German army. Amidst the sounds of gunfire on the Russian front, he accurately solved Einstein's field equations, describing the gravitational field generated by point mass and spherical mass. He sent his findings to Einstein, who was astonished by the precision of the solutions. Schwarzschild uncovered something unexpected even to Einstein. If a celestial body's entire mass is compressed within a minuscule gravitational radius, all matter and energy, including light, would be trapped inside, unable to escape. This celestial body would appear as complete darkness from the outside, which is a black hole. Although Einstein's general theory of relativity predicted black holes, he doubted their existence in reality. Schwarzschild passed away before his paper's publication, and the black hole theory was almost forgotten in subsequent decades. However, later studies of nuclear fusion processes suggested that black holes might stem from stars. Stars share many similarities with living beings, such as humans, in that they possess their own life cycles. Early stellar life cycle researchers, Subramanian Chandrasekhar and Robert Oppenheimer, found that a star's destiny hinges on its mass, which dictates its ultimate fate. All stars undergo hydrogen fusion, transforming hydrogen atoms into helium and subsequently heavier elements. Gravity pulls the star's mass inward, while the immense energy released by fusion counterbalances the star's gravity, preserving its structural stability. For massive stars, fusion ceases upon reaching iron, a stable element that releases less energy during fusion than required. Consequently, the star's internal energy can no longer withstand its gravity, leading to the star's collapse and a subsequent powerful explosion, resulting in a supernova. If the remaining mass is ample, gravity continues to compress matter towards the center, eventually forming an infinitesimally small volume with almost infinite density. Once the radius diminishes to less than the Schwarzschild radius, the mass-induced space-time distortion becomes so intense that even light cannot escape, giving birth to a black hole. In reality, between the 1930s and 1950s, numerous astrophysicists, Einstein included, harbored doubts about the existence of black holes. It wasn't until the 1960s that the concept of supernovae giving rise to black holes captured the scientific community's interest. Princeton physicist John Wheeler determined that any star with a mass exceeding 10 times that of the Sun would ultimately transform into a black hole, suggesting their abundance in the universe. As a result, many scientists embarked on a quest to discover these remarkable celestial phenomena. On April 10, 2019, astronomers unveiled the first ever image of a black hole. The surrounding orange glow results from the radiation emitted by matter being pulled into the black hole, with the black hole itself at the center. Unfortunately, Schwarzschild, who had predicted black holes through equations over a century earlier, never obtained the recognition he deserved within his lifetime.